going to do a demo to quickly show you how I use the Hadoop MapReduce framework to catalog the breast cancer histology dataset in the HDFS. And then I'll just also show basically how I visualize the results in Python. We'll start by looking at the dataset that I used and then go through the Java code in Eclipse, which basically contain the logic for the mapper and the reducer jobs. And then I'll run both jobs, or rather I'll show how I ran both jobs in the Windows command prompt. And then also show the progress or the outputs in the Hadoop web interfaces. After that, I will show how I exported the results from both the mapper and the reducer. And then also just take you through the Python script where I was basically interpreting the results. And then we'll also just quickly look at the GitHub repository that I created, basically just showing all the code that I committed there. Okay, just starting with the dataset. This dataset basically has a test set and a training set. So for this assignment, I just used a training set, which was about 13.26 gigs. So just looking at it, we have the WSI, which is the whole slide images. So in general, these are slightly bigger images compared to normal images. So they are the SVS file type. And then we just have some thumbnails here, which are quite smaller in comparison. And basically, these are good for quick prototyping. So before then building out the model in scale. So other than the whole slide images, we also have the microscopy patch images, which are separated into different classes. So we have the normal class. So in general, these are the TIFF file extension type. And then we also have invasive, in situ, and benign, and so on. For the next part, we're just going to look at the code in Eclipse. So basically the logic for the mapper and reducer jobs that I'm going to run in the, or that I ran rather, in the command window prompt. So starting with the POM file, this is basically the file that declares the dependencies and builds a shaded jar file that we can run with Hadoop jar. And then next, I'm just gonna quickly look at the utils class. So this class basically contains the helper methods for passing, extensions, and label inference. So basically, yeah, this is what helps us to read the different files from the class folders, as well as the whole slide images and the thumbnails. And then we have the image meta job, which is responsible for the mapper part of the MapReduce framework. So this class does the map only job, which emits one TSV row per image file. So that's the tab separated values file, which contains the path, extension, label, acquisition type, bytes, width, height, and pages. Lastly, we have the label stats job, which is the reducer part of the MapReduce framework. So this is the second job. So this reducer groups by label, and it computes average size in megabytes, minimum and maximum width and height, and average pages. Okay, so the last part in Eclipse is to basically create the jar file, which we do by right-clicking on the main folder, and then going to run as, and then choosing Maven build. After we choose Maven build, we then type in clean package here, and then we run. So that's basically creating our target jar file, which we're gonna utilize in the command window shortly. Okay, once the build is successful, as we see there at the bottom, then now we can move on to the command window. Okay, on the command window, we start everything using this start_all.cmd command, which basically starts the Hadoop name node, the Hadoop data node, the Yarn resource manager, and the Yarn node manager. Okay, once we have that, basically the first thing that I'm doing here is to then change folders to the Git repository, which basically, since I had now committed the code, that's where the main folder of the Java code is. And then after that, just start by basically confirming the target existence of the target file. So that's what is showing here. So I just start by cleaning out the old outputs using these commands because I had done some updates. And then after that, we then set the path for the target jar file. So that's what this command here is doing. And then we are ready to run the mapper job. So this is basically the mapper job running. And then after it was done, we're able to see that it completed successfully. So we're just seeing a bunch of results here in terms of the job counters, and then the number of bytes read, number of bytes written, just the memory stats as well. I then switched to the outputs folder where basically I wanted to store the outputs of the mapper and reducer jobs. And then I just wrote out the TSV file that it produced to that folder so that I can use it later in Python. And then after that, basically with this command, I'm running the reducer class now. So this is basically the reducer class as it runs. And then after it was done, similar output to what we got after we ran the mapper class. And then after that, similarly, I wrote out the results to the outputs folder for analysis in Python. Before we go to Python, I just want to quickly show the output as showing on the Hadoop web interface. Okay, so starting with the output of the mapper job. So just opening one and looking at the head of the file, this is basically what it's showing. I'm seeing it's an SVS, which means basically it's one of the whole slide images. And then checking the output for the reducer class, which is the label stats. So basically we just have this success line here, basically just signaling that our job was successful. And then this is the one output. Basically, if you look, it's just showing the stats in terms of the classes, the count, and then the average dimensions in terms of width and height, as well as the average size in megabytes. Okay, the other part of this Hadoop web UI is this cluster, localhost cluster UI. So the final part of this is looking at the Python analysis, which is basically just analyzing the outputs from the Hadoop framework. So we have a couple of visualizations, starting with this bar graph showing the files by label. So basically this tells us that our dataset is balanced and hence our results won't be skewed towards any particular class. So for our model, we should be okay on that aspect. And then we also have another bar graph just looking at the average file size by label. So in general, the microscopy pictures, these ones separated into classes, are quite small, about 17 to 18 megabytes. And then the unknown class here, which is mostly made up of the whole slide images, in general, the average file size is about 80 megabytes per image, which is quite big. The insights we can get from this speaks to basically forecasting backup costs, data storage growth, as well as replication. So IT can basically see how many whole slide images we have and then be able to cater for that. So if we have a lot of them, for example, then we need to ensure that we have the necessary infrastructure to handle that. We don't need to worry as much about the microscopy ones since they are generally smaller. It can also help forecast basically ingestion SLAs when we have to ingest data overnight, basically how long that is going to take and the type of infrastructure we need to basically make it quicker depending on the number of whole slide images that we have. It also helps us make pre-processing choices. So for example, with whole slide images, you usually need to do some tiling Or do we rather use the microscopy patch photos and also just decide on the batch size and GPU memory planning? So depending on how many whole slide images we have compared to the microscopy patch photos. And then we just have this dimensions one. In general, also speaks to size because the higher dimensions will be higher resolution photos, which are usually the whole slide ones, with most of the microscopy patch ones clustering here at the bottom with the 1500 by 2000. Lastly, we have the Spearman correlations, looking at the four aspects of our data. We have the size in megabytes, we have width, height, and pages. So in general, there's a strong positive correlation between megabytes and width. So basically, if you look at the width in the megabytes, it's about 0.88, which makes sense because in general, that's the size. And then we also have moderate to strong correlation between pages and megabytes, which again speaks to the size because if we have a lot of pages, then it's likely a bigger photo. So in general, this can give a sense of how big our images are and then help IT to plan better in terms of the data storage costs as well as the backup costs, and also strategies on streaming in terms of data ingestion. Lastly, this is the code as committed in GitHub. In general, there's this batch MapReduce folder that contains the code in terms of the mapper and the reducer, as well as the utils class. Lastly, I have this README, which basically just highlights what the repo is about at a high level. Thank you.